What is the ideal wall thickness of an injection molded component? Determining the ideal wall thickness of an injection molded component depends on several factors, including the material of the component, the desired strength and stiffness of the component, and the size and shape of the component. In general, the ideal minimum wall thickness will be thick enough to provide the necessary strength and stiffness, but not so thick that it adds unnecessary weight or cost to the component. Several methods can be used to determine the ideal wall thickness of an injection molded component, including the following. The rule of thumb method. This method involves using rough estimates of the required proper wall thickness based on experience or industry general material thickness guidelines. While this method is quick and easy, it may not always produce accurate results and may not be suitable for more complex component designs. The elastic method. This method involves calculating the required plastic injection molding uniform wall thickness using the elastic properties of the material. This method is more accurate than the rule of thumb method, but it requires knowledge of the material, as modulus of elasticity and Poisson, as ratio. The plastic method. This method involves calculating the required appropriate wall thickness using the plastic properties of the material. This method is more accurate than the elastic method, but it requires knowledge of the material, as yield strength and strain hardening exponent. Finite element analysis. This method involves using computer software to simulate the behavior of the component under different loads and to calculate the required optimal wall thickness. This method is the most accurate but also the most time-consuming and complex. In general, the ideal nominal wall thickness will be thicker for larger and more complex components and materials with lower strength and stiffness. It is important to carefully consider all of the factors involved in the component design to ensure that the wall thicknesses are appropriate for the application. There are several factors to consider when determining the ideal wall thickness for an injection molded component. Material properties. Material being used for the component will have a significant impact on the ideal wall thickness. Materials with higher strength and stiffness will require a thicker wall thickness to achieve the same level of strength and stiffness as a component made from a material with lower strength and stiffness. Size and shape of the component. Size and shape of the component will also affect the ideal wall thickness. Larger components will generally require a thicker wall thickness to maintain the desired strength and stiffness, while smaller components may be able to get away with a thinner wall thickness. Similarly, components with more complex shapes may require a thicker wall thickness to maintain strength and stiffness. Desired strength and stiffness. Desired strength and stiffness of the component will also play a role in determining the ideal wall thickness. If the component needs to be strong and stiff, a thicker wall thickness will be required. On the other hand, if the component does not need to be as strong and stiff, a thinner wall thickness may be sufficient. Tolerances required for the component will also impact the ideal wall thickness. If tight tolerances are required, a thicker wall thickness may be necessary to maintain the necessary accuracy. In general, the ideal wall thickness for injection molded parts components will be determined by a combination of these plastic injection molding process factors. It is important to carefully consider all of these factors to ensure that the component has the desired strength, stiffness, and accuracy.